Have you ever wondered, why exactly does light have to travel in a straight line when it can go like this or this? Similarly, why does the electron have to follow this one particular orbit around the nucleus when it can go like this or this? From what you observed, you might think that things like light and electrons prefer certain paths over the others. Now, why is there such a preference? Do they have a mind which tells them to prefer one path over the other? The answer to our questions is this equation right here. Now don't worry, I'll explain it in simple terms. This equation is Feynman's path integral formulation of quantum mechanics. It's also called the sum over histories method. Path integral literally means sum of paths. You have this point particle at A. To calculate its probability of arriving in B, you have to consider all of the possible paths in space and time between A and B. As Murray Gell-Mann said, everything not forbidden is compulsory. But each compulsory path doesn't have an equal probability of getting taken. In this equation, we have each path multiplied with this block, which indicates that path's probability amplitude. So, if a path has a greater probability amplitude, its weight is greater. Then you sum all of these up. As you sum them up, the paths with greater amplitudes have a greater contribution to the final sum of paths. I just said sum of paths. How exactly do you sum paths up? Actually, what you add in the paths are their probability amplitudes. And since amplitudes are properties of waves, we should just be adding waves. Here we have the perfect principle telling us how to add waves. The principle of superposition. When two waves interfere like these water waves, they add up to produce a final wave. Let's illustrate this with my device right here. We have two waves. When crest meets crest, notice that the wave sum they make is a wave with higher amplitude. It's like their amplitudes reinforce each other. This is constructive interference. Now when I push this farther, such that crest meets trough, they should produce destructive interference. Notice that their amplitudes cancelled out into a flat line with zero amplitude. Their amplitudes just mutually destroyed each other. Back to the question at the beginning of this video. Actually, what the light and the electrons did is they tried all of the possible and compulsory paths. But the preferred paths we saw, the straight photon path and the circular electron path, are just the result of the constructive, mutually reinforcing, coherent, and synergistic interference of the paths. And because of their huge contribution to the final amplitude, they had the most probability of being observed by us. Now, why do I consider the path integral as perhaps the greatest generalization in physics? When you think about it, the essential idea behind the path integral can be applied to all of the interacting systems in the universe. An entity, be it an electron, an atom, a person, an organism, or corporation, or a country, can do anything it likes. However, only those constructive, coherent, harmonious, and synergistic interactions survive and thrive. On the other hand, destructive and incoherent interactions lead to mutual annihilation and destructions. So, as time goes by, we see more incoherent entities disappear and the coherent ones remain. This is evident in the beautiful and seemingly orchestrated evolution of things, from atoms, matter, organisms, and galaxies, to socio-political structures and even human affairs. Perhaps even to all interacting entities in the entire universe. So in summary, what the path integral teaches us is that the most probable or the most preferred path is the path towards harmony, constructive interaction, coherence, and synergy.